So for number 10, it's asking us to identify the vertex of the parabola, which basically means that we are going to enter this graph into Desmos and then label the parabola. So it would be best if you just enter in your multiple choice solutions, because what you want to do is you want to make sure that the fraction equivalent matches the decimal that's in Desmos. Unfortunately, Desmos does not give you the fraction equivalent. It only gives you the points on the graph in decimals. Okay, so you should also know that if I have a vertex and my graph looks like a hill, that's a maximum. And then if my graph looks like a valley, that's a minimum. So in this case, our vertex is going to be negative 8/3, comma 43/3. Okay, so for number 10 or 11, the axis of symmetry, it's going to say f of x equals negative 4 times x minus 5 squared minus 14. So this is a parabola. The axis of symmetry is going to be the center of the graph, so it's the x value of the vertex, and it's going to split the graph in half. So what I've done is I've graphed this in Desmos, and then I put in one of my answer choices. We know that it's going to be an x is equal to some value, so it's an equation. So in this case, x is equal to 5, and if we illustrate that in Desmos, when I have the equation of x equal 5, it takes that parabola and it splits it in half. So this is our solution. So this is the next one. It says find a polynomial function f of x of least polynomial or least possible degree having the graph shown. This is going to be an even upside down function. So your leading term on this is going to be negative. Now let's talk about the multiplicity. The multiplicity here has to do with the multiplicity here has to do with the way that the x-intercepts behave on the x-axis. Because they have a bounce, we know that these x-intercepts are going to be, each of them is going to be squared. So whatever the linear factor is, like x plus 3 squared, x minus 1 squared. And then when you build a template for the polynomial, you're going to use the y-intercept to find the a, and the a is going to be your stretch or your compression. So this part right here is called multiplicity. If it crosses the x-axis, then it's x to the first. I'm sorry, the x-intercept is going to be to the first power. If it has a wiggle, like a cubic wiggle or something like that, it's going to be to the cube. The x-intercept is going to be to the cube. Just go ahead and see what this looks like. So the x-intercepts are going to be x equals negative 3. So the first one is going to be x equals negative 3. We have to solve the linear, or we have to create the linear factors. So I add 3 to both sides, and I get x plus 3 squared, again, because they touch the x-axis. We call that a bounce. And then the second one is going to be x equals 1. So then I'm going to subtract 1 from both sides, and then I get x minus 1 squared. Again, they're both squared because they're a bounce off the x-axis. And then we have the y-intercept. That's going to help us solve for a. So the y-intercept is 0, negative 18. That means that x equals 0 and y equals negative 18. So then we're going to substitute that into our template, and we're going to use that to solve for a. So the template right now with the x-intercepts are going to be p of x equals a, x plus 3 squared times x minus 1 squared. And we're substituting the 0 right here, and the negative 18 goes right here for the p of x. So then I get negative 18 equals a times 0 plus 3 squared times 0 minus 1 squared. So then I get negative 18 equals a times 9 times 1. And then bring that all together. I get negative 18 equals 9a divide both sides by 9. A equals -2. So then I can now write my polynomial. So together it's going to be P of x equals -2 times x plus 3 squared, x minus 1 squared. And that's going to be what I have here on the right hand side using Desmos. You can just type it in to verify the polynomial. That's what I would do on the test. I would just go through the answer choices, type them into Desmos, and match the attributes. The attributes that we're talking about are going to be the intercepts. So first is going to be the x-intercept. That's the first one. That's the second one. And then that's the y-intercept. And they're all labeled. Okay, so for this next one, what you're going to do is you're going to look at the end behavior. The end behavior is just what's happening on the left and the right hand side of the graph. So you have 4 different types of end behavior based on your leading term. So you have a positive function, which means that your leading term is going to be a positive number. In this case, it's a negative number. But if it was a positive even term, your ends would be going up. And then you have a negative even term, which is what we have here. We have a -3 and it's raised to the exponent of 6. That's an even exponent. So our ends are going to be going down. And then on top of that, you can also have a positive odd function, which means the left hand side is down, the right hand side is up. And then you can also have a negative odd function, which means left side is up, right hand side is down. So in this case, our answer is going to be C. And it's going to be C because as we look at the graph, what I've done is I've typed in this function over here. It's hard to see because the screen is smaller all the way to the end. All the terms are there. Our graph, it doesn't matter what's happening at the top of the graph, our graph opens downward. Okay? For the next equation or the next problem, it says give the equations of any vertical or horizontal asymptotes. So the first thing we're going to concentrate on is going to be the horizontal asymptote, which is going to stand for HA. If you recall, the degree on the top, or when the degree on the top is less than the degree on the bottom, then your horizontal asymptote is automatically going to be y equals 0. So this has a degree of 1. That's the numerator, and the degree of the denominator is 2. Now, another thing we have to recall about rational equations is that the denominator contains the vertical asymptotes. So in this case, our denominator is x squared minus x minus 12. We're going to go ahead and have to factor the denominator. So I'm going to get x minus 4 times x plus 3, and then solve for the variable x. So x minus 4 equals 0. Move over the 4, x equals 4. And the second one is going to be x plus 3 equals 0. Move over the 3, x equals -3. So that's going to be those are the equations of the vertical asymptotes right here. Let's go ahead and illustrate this when we graph it. It's going to be y equals 3x minus 4. And then we're going to divide that. Oops. Excuse me. I don't know what I'm trying to do here. Oh, I'm trying to make a fraction. Then you're going to divide that by x squared minus x minus 12. And then what I like to do is I also like to type in my asymptotes so that we can get a visual representation. So in the answer choices, it's going to give you the asymptotes. If I were you, I would just type in the equation, type in the asymptotes, and see what you can observe, like what looks the same. Okay, so in this case, we're going to need to press the home key. So we have the y equals 3x minus 4 divided by x squared minus x minus 12. So let's see. The horizontal asymptote is definitely y equals 0, and it's equivalent to the x-axis. I can make this a little bit more distinct for you. So you can see that. And then starting on the left-hand side, x equals -3 is the first vertical asymptote, and the second one is going to be x equals 4. So again, the asymptote is going to be a value that the function gets very close to, right? I hope this was helpful. You'll be able to see both. There you go. It's even more apparent when you change the lines. Remember to use Desmos on your test.